gave you triangle DEF on purpose because I knew that in the note, our first triangle, actually both our triangles are ABC, right? So now we get a chance to redo what we just did, right? To really solidify the derivation of this. All right. So today's learning goal, use basic trig ratios to determine the area of a triangle, and then use sine and cosine law for a combination of both triangles. So first we're going to talk about how to find the area of a triangle. We'll practice it, and then we will do a couple of problems requiring cosine sine law. So this little thing is a bit of a sidestep. All right, so here we have a triangle ABC. We know that the area of ABC can be found by doing base times height divided by 2. In addition, I don't like that the base is actually a b. I'm like, I can be given the base. Right? It looks like I just wrote b twice, but I'm like, I can be given this piece of information, right? So then the whole trick is, how do I find the height? I'm going to make that pink. And now we're like, I know what I'm doing. All I have to do, and this is part of it, the height is always a vertical line, right? That's what makes it possible for us to use SOHCAHTOA. So if I draw this triangle on the side where I have A, B, and then just a random point here, and this is side C, I'm like, okay, actually, I'm going to even erase the B because this is not exactly angle B. I'm like, wait a second. So if I know this angle, that means I can label this triangle based on angle A. So this is opposite, this is hypotenuse, this is adjacent. I've got the angle. I can get the measurement of side C. And I don't know the H, but I can find it. I've circled O and H. That means I'm using sine. So I'm going to have that sine of A is going to equal to opposite over hypotenuse. In this case, my opposite is the height, and the hypotenuse is side C. Now, I can give you the angle A, and I can give you side C. But we are actually looking for an equation to express the H. So let's multiply both sides by C, and we get that H equals C times sine A. And so now we can take this expression and plug it into this equation where we know that the base has been given and the height has not been given, but we can write it as C sine A and all of that divided by 2. So the area of ABC can be found using two sides and an angle. Right? This is basically what you guys did. Just you had a lot of extra steps because you were still thinking about it, right? And a lot of you guys, I was like, you guys overthought it. You're doing too much work. But that's okay because that's going to happen when you're deriving an equation. It's not going to be a straight line. You're going to do a lot of side steps. Okay. Well, the question is, does it work for a triangle that is, what do we call this triangle? Anyone know? It's based on angle C. It's an obtuse triangle, right? This is obtuse. And it is obtuse because there is one obtuse angle. What is an obtuse angle? Greater than 90. Obtuse is greater than 90 degrees. So the question asks, can we do this for an obtuse triangle? Well, let's see. The formula we had is that we need the base, we need side C, we need angle A. So for this triangle, do we have the base? Yeah, this is the base. Okay. And then we need to find the H. So it's a bit different because now the right triangle is outside of the actual triangle, right? It's not like we did an inner triangle. So we've got this outside triangle. What do I know in this triangle? Well, I know this side. I do not know the length of the bottom side. I know this angle. I do not know angle B, right? Because it's bigger than the angle that would have been given to me. I know this is a right angle. So using that, and I know I'm looking for the H, which trig ratio would I be using to solve for the H? So I've got an angle. This is my opposite. This is my hypotenuse. I would once again, yeah.
I just have a separate question. Why can't you rotate the triangle and use C as the base?
You absolutely could. Yeah. Yeah, you absolutely could use C as the base and then do the same thing where you're like, well, the height is inside the triangle. Yeah, but I want to show you that if it's an obtuse triangle, this is actually still going to work out just the same. So what is the height going to be? Well, the height would be, or it would be sine A equals opposite over hypotenuse. Oh, wait a second. That's the exact same thing we did. So the question is, does this formula work for obtuse triangles? Yeah, it works the exact same way. Okay? So we use the same formula. We can use this formula for obtuse triangles. And so as a summary, here are 3 examples of a formula. Now, what do we notice about this? So if the angle is A, we're using the other 2 sides, the 2 sides that are touching the angle, right? If we look at this triangle, if this is the angle we use, we need the base and we need this side. So once again, it's an SAS situation. Okay? This is an SAS. So notice when I'm using angle A, I don't use side A. So for example, if I had a triangle DEF and I used sine D, which sides would I use? E and F, right? The other 2 sides. Okay? I will give you one of these formulas on the quiz, but guess what? The triangle will definitely not be an ABC triangle. So the hint is just to remember whichever angle you use, you have to use the other 2 non-corresponding sides. All right, let's practice. And you know what? Just for the sake of practice, let's call this triangle. I'll just put some random letters. Okay. Do you like the randomness of these letters? They just came up like that. All right. So let's find the area. Okay, let's look at what we have. We have 2 sides, we have an angle. Can we use it? Yeah. All right, let's give it a shot. Right? And as you notice, I use a subscript to write the name of the triangle. Oh my God, it's my last name. I didn't even realize I did that. All right, before you put numbers in, write the letters. Did you catch that, Marley? No. You didn't, right? First, no, I know. I realized. Yeah. Yeah. A little slow on the uptake. That's okay. It's the morning. All right. So before we put numbers in, let's write the actual formula. Okay. So because I have angle S, now can I figure out angle L or Y? I could, right? I could use sine cosine law. But because I have the side angle side sandwich, I'm okay. So I'm going to write which sides I'm using: side L, side Y, and angle S. All right, let's plug that in. All right, and then everyone's taking out their calculator. And what does the question say? How do we round? To the nearest tenth. How many decimals is the nearest tenth? 1 decimal. Beautiful. All right, give me a number. Give me a number. 0.5. Is that the correct rounding? Everyone agreed? All right. Am I done? Come on, Luke. Help me out. I'm not done. Miss Sly, you're going to lose some marks.
You have to write whatever this thing centimeters. True. Or centimeters squared.
Excellent. We're talking about area. It's a 2-dimensional measurement, so we add a 2. All right. We good? So the trick of this part of the lesson was really deriving the formula. Using the formula is quite simple. Make sure that the 2 sides are on either side of the angle. All right. Let's take a bit of a jump back to the sine and cosine law. Okay? And folks, I want to check in with you, or I want you to check in with yourself. Did I do my homework? Am I sitting on my phone right now? Are you doing well with the game? Yeah. Okay. Am I sitting on my phone? Am I paying attention? Am I asking questions? Because folks, this is a review quiz in theory, right? Most of this stuff is review. So that means, oh, I could do really well on this quiz if I properly prepare myself for it. Okay, this is your chance. All right. In example 2, determine the measurement of angle C to the nearest degree. I'm going to circle this because I don't want to lose marks for rounding incorrectly. Okay, I've got 2 triangles. What did Miss Sly say about the 2 triangles? Anytime you're given 2 triangles, you're probably going to have to start with the other triangle, right? Why would they? It's like, why would they give you this other triangle unless they want you to work with it first? So I'll look at triangle CBD. Do I have enough information? Sir, take that back. How many pieces of information do I have in triangle CBD? 2. Is that enough to solve the triangle? No. Look at triangle BAD. Do I have enough? Yeah. Isn't that so bad? Wah, wah. I said bad. All right. Let's work in triangle BAD. Now watch this. This is how I communicate what I'm working in. I'm working in triangle BAD. I'll either use a colon or just underline it to be like, this is work inside this triangle. Now, I don't want to do too much work. Can I solve BAD? Yeah, but why would I? I need literally one piece of information from BAD. And you know which one it's going to be? It's going to be the one that it shares with the other triangle. So what is it? It's going to be side A, right? So I need to solve for side A. And now we, sure, yeah. Or you could call it side BD, or you could call it X. All right. So take a pause, talk to your partner. Are we doing SOHCAHTOA, sine law, cosine law? You cannot do any of them.
Sorry, miss. You said we can't do any of them.
Someone said you could do any of them. And I said, no, I don't agree. All right. Why can I not use SOHCAHTOA?
No right angle.
No right angle. Gorgeous. Why can't I use the sine law? No, the sine law.
Not enough angles.
So remember, with sine law, I said you need one complete pair and one incomplete pair. Is there a complete pair? No. That's my reasoning for not being able to use sine law. So what's left over? Cosine law. Now, there's a reason why I know I can use cosine law, because it is the SAS. It's the side angle side sandwich. Okay, so, I've got the side, the angle, the side. Okay, it is SAS. So use cosine law. Now, I'm not going to look back at the formula. I'm going to tell you how we're going to try to do this. Okay, I'm solving for a squared. So the first thing I do in this formula is I add the sum. I find the sum of the square of each side. So I'm going to do b squared plus d squared, right? That's how every cosine law starts. You add up the other two sides. Then you go minus 2 times each of those sides. So times BD, and then cos of angle A. All right, let's pop in our values. B is 18. Times 15 times cos of 65. All right, the only possible mistake you could make here is that you might incorrectly use your calculator. And as such, it is imperative that you use your calculator right now. And remember, we're solving for a squared. So as such, we do what to find A? We will eventually, yeah. And so you don't have to actually write the value that you get for A squared. You can punch square root in your calculator and just give me a value for A.
17.9.
Yeah, I like that. And I like that you're using one extra decimal, right? Because you probably didn't do it on purpose, did you? You did, of course. So the question is saying to the nearest tenth. So as you're working on calculations throughout the question, do at least one extra decimal place. Okay, no units here, so it's just 17.91.
It says to the nearest degree.
Oh, to the nearest degree, that's right. Okay, so 2 decimals, that's cool. Because we're not at the end yet. It's just for angle C. All right, let's move into triangle CBD. So are we, did people agree with the 17.91?
Yes.
Okay. Out of curiosity, what do you think about the angle that we're going to get for angle C? Like, make a prediction. Is it going to be little? Is it going to be big? Is it going to be greater or less than 90? I want everyone to think about this. Okay, I'm hearing a lot of obtuse, right? And we're like, yes, because if one of the sides is 9, one is 10, and then this side is 17.91, it's going to be ginormous. Is this even possible for a triangle to have these measurements?
No. Yes.
I'm asking. What would be an impossible measurement for x? Annabelle. Yeah. Why 19? Think about it. We got 9, 10, 19. What would this triangle look like if this was 19 long? What would it look like? This side and this side together are 19. So if this is 19 long, that means it collapses and it's literally a straight line. So the greatest possible measurement for x is like 18.99. And in that case, this angle would be ginormous, right? Really close to 108. All right, so we've made a prediction, right? We're using our critical thinking. All right, I know in this case, I've got S, S, and S. I've got the 3 sides, which means, sorry, I'll turn that off. Which means, what am I using? When you have SSS, is it sine law or cosine law? Why is it definitely not sine law?
Because you have SSS.
You don't have a complete pair. So we're going to use cosine law. Just keep guessing. But because you need a complete pair for sine law, you're like, I don't have an angle inside that are corresponding. So in this case, okay, this one I don't know off by heart. Let's look at this formula. Yeah, it's this one. All right, but I try to memorize how to write it. So watch this. If I'm solving for angle C, I add the other two sides. I subtract C squared, and then at the bottom, I've got the other 2 sides. Yeah.
But what if we don't have a triangle ABC?
Yeah, you've got to figure this out.
Then can we just pretend that A value would be the top?
No, I want you to figure it out. You can do it. All right. So what we know is that sine of C is going to be the other 2 sides squared. So it's going to be B squared plus D squared minus C squared.
It's not sine, but
Cosine. Oh, watch this. Bang. Or I guess I just want to say cos. And then at the bottom, it's twice the length of the other 2 sides. So 2 times BD. So I've got 10 squared plus 9 squared minus 17.91 squared over 2 times 10 times 9. And will it give me the angle C? Or is there another step? I have to take the cos inverse. In terms of calculation, I encourage you to put brackets around the numerator and brackets around the denominator, just as a safety net. Thank you.
No, it's always good.
It's not, but good. Good, I'm glad.
I would say.
You're funny. Always.
Yeah, 100%.
All right, now I want the exact answer. What is it? Yeah. 141. Do people agree?
Yeah.
Not 142, not 140. Excellent. Good. Thank you. Therefore, we found it.
Approximately.
Ooh, thank you. Oh, we forgot this approximate. Yeah, that is communication marks. Absolutely. Even on your test, you put them, other people didn't. Yeah. Um, okay. Does that align with our prediction? It does. We said it was going to be an obtuse angle, and it is. Gorgeous. Love the brain. All right. Yay. We've got a three-dimensional question. Man, I love this. All right. Let's take some time. Let's read the question. If you're confused, what are you going to do? Read it again. Okay, read it 3 times. Underline, draw. What do we got here? Okay. All right, folks, we're all reading now. Luke, tell Liam to stop talking to you.
I know. I got the answer wrong in my calculator. Let me see.
Okay, that's a good question. Yeah. Mm-hmm.
In every triangle, all angles must add up to 180, right?
That's right. That's the sum of angle law. All right. Who's heard of a theodolite? Okay, a theodolite, think of it this way, is an instrument that is on a tripod that someone will use to measure the angle between 2 places, right? So you're far away, you're starting with the horizontal, you go up to the top of the cliff, and that will give you the angle between the horizontal and the cliff. So when they measured it, they got 31 degrees. So they're like, oh, the angle of elevation is 31.1 degrees. Now, that's not the height, but what it is we can actually use that to calculate the height. So this is how you're able to calculate heights of things that are very far away. But they're talking about this theodolite, and because it's an instrument that is tall, once we find the height, we need to add the theodolite. Okay, because the height is measured from here in the triangle, so we have to add the 1.7. All right, we got 2 triangles. We're trying to solve for h. Are you guys working on it, right?
Yes.
Cool. Do we have enough information in this vertical triangle? I got an angle. I got 2 angles. Is that good? No. No. And so because there's a second triangle, I'm like, oh, of course, they're going to make me do more work. They're going to make me start with the lower triangle, right? X, B, W. How many pieces of information do I have in this triangle? 3. Good. Now, what can I definitely not use for this lower triangle? SOHCAHTOA. I can't use SOHCAHTOA because, tell me about this triangle.
I don't see a right angle.
I don't see one either. It's not a right angle triangle. I mean, it might be, but we can't guarantee it. So we've got angle, side, angle. Do I have any complete pairs there? No, I don't.
I think I see.
So for cosine law, I do SAS. Do I have SAS? Nope. Do I have SSS? Nope. So I guess we go home? Like, that's it? Yes, Timon.
We need to find another angle and then.
All right. Can I figure out this angle?
Yes.
In that case, do I have a complete pair? Yes, I do. So which law am I using? Sine law. All right. So now, in this case, again, the first thing I'm like, oh, this is the side that both triangles share. So I'm going to find the measurement so that I can transfer this knowledge to this vertical triangle. That's what I'm trying to solve for. Okay? So step 1, we're going to work in triangle VXW, and we're going to find side W. Now I'm actually going to redraw it just so I can visualize this in 2 dimensions. So this is W, X, V. This is little v. This is 90, which is little x. This is W. Okay, I know this is 35.8, and I know this is 44.2. All right, let's start off by finding angle X. Right, and we're going to use sum of angles. So 180 degrees, subtract 35.8, subtract 44.2, 36, 40. So I think it's going to be 100. Would anyone agree? Okay. So we've got angle X. Good. Now, so because this is 100, I'm like, so I've got a complete pair and 2 incomplete pairs. And it's really important that right now we pause and we choose the incomplete pair wisely. Do I want to solve for V or W?
W.
Yes, I want to solve for W because that is the side that is shared by the other triangle. All right, so we're going to make W the other incomplete pair. So step 2 in this calculation is going to be to use the sine law Okay, and do people remember and like the T rule?
Yeah.
Okay, so I'm going to go 90 times 44.2 divided by sine 100. What is it? 60.
63.71.
Okay. And I like that we're using extra decimals. Now, help me, folks. I just lost a communication mark.
You have to do the approximate equal sign.
Love it. All right. Did I have to do the approximate here? No, because I didn't round. All right. So I've got W. So now we can move on to the next triangle. Let's choose a nice, I'll do orange. So step 2, we're going to work in triangle VYX. Could I have called it XVY? Yeah, sure. So in this triangle, let's draw it out. Yes.
Were we given this formula for
Yes. For the quiz, you mean. You will be given a version of each formula using ABCs, but each of your triangles will not be an ABC triangle. Does that make sense? Yeah. Ooh, it's a 90-degree. It's a right triangle. Well, doesn't that make our life easier? Okay, what do we know? We know 31.1. I know I'm solving for H. And where do I put the 63.71? Because there's no W here. Where do I put it?
side Y?
Yes, at the bottom here. 63.71. I'm like, where do, oh yeah, it's the bottom of it. It's right between the 31 and the 90-degree angle. Okay. Do I have enough information? Well, let's see. I've got angle, angle, and side. I've got 3 pieces of information. Let's see. If I circle the angle I've got, and I circle what I have and what I need to solve for, This is the opposite. This is the adjacent. And I don't need to use hypotenuse. And this means I'm going to use which ratio? Yep. And I can use a ratio because I've got a 90-degree angle. So I have tan of 31.1 degrees is going to be opposite over 63.71. Oh, pause. Here's the question. Is the height going to be greater or less than 63.71? Because how do you know that angle Y is smaller? We didn't calculate it. Sorry, angle Y is not smaller. Angle Y is bigger, right? It's going to be 90 minus about 30, so it's going to be approximately 60 degrees, right? Okay, good. So we're looking for something smaller than 63. And if I don't get it, I might have made a calculation error. All right, so H equals 63.71 times tan 31.1. What do we got, folks?
38.43.
Okay, but at this point, I want a complete answer to the nearest tenth of a meter. So 40.
0.1. It's adding this.
Oh, whoa, not yet. No, what is the height? What is the H? 38.4 meters. Yeah. Say it again. H or V? No. But we are not done. Why, Luke? That thing, the theodolite. Okay, so we got 38.4 plus 1.7, right? That machine was 1.7 off the ground. So that makes it 39, 40.1 meters. Therefore, the cliff, right? Oh, yeah, we're measuring the height of the cliff is 40.1 meters high. Yeah, approximately. Thank you. I do that on purpose so that you have to remind me. Folks, you have worked your brain so hard today. I'm so proud of you. Yeah.
When solving for height, can I use sine law instead of tan?
You can use sine law and it will work.